Good morning, students. This is the second lecture on water. In the last lecture, we had discussed about the general introduction, distribution and impurities in water. We also discussed about hardness of water, different types of hardness, and we compared temporary and permanent hardness. In this lecture, we will discuss about measurement of hardness, and we will also calculate hardness in the different water samples. So these are the contents of this lecture. We will study degree of hardness. We will calculate hardness in terms of equivalents of CaCO3. We will study the different units of hardness, and we will also take up numericals based on hardness and interconversion of different units. Now, what is degree of hardness? So here it is very important to mention that hardness is due to a large number of salts like calcium carbonate, calcium sulfate, calcium chloride, magnesium bicarbonate, magnesium sulfate, magnesium chloride, etc. But irrespective of the salt which is causing hardness, hardness is always expressed in terms of equivalents of CaCO3. Now the question arises, why hardness is chosen in terms of equivalents of CaCO3? So there are two very simple reasons for this. One is that the molecular weight is 100, so the calculations become very easy. And second, it is the most insoluble salt, so it is possible to precipitate and then you can verify the result in real terms. So, whenever you are calculating hardness, irrespective of the salt which is present in water, you have to first convert it into equivalents of CaCO3 and then you have to proceed further. Now the question is, why are we converting it into equivalents of CaCO3? Now the basic reason for this is that suppose you have 3 water samples, 1, 2 and 3. Say you have a water sample A, you have a water sample B, and you have a water sample C. Now, what you have, say you have 1 milligram per liter of Ca calcium bicarbonate in the first sample. You have 1 milligram per liter of calcium sulfate in the second sample. And you have 1 milligram per liter of, say, magnesium chloride in the third sample. Now, if someone asks you which of the sample is the hardest and which is the softest, then with the help of this data, are you in a position to define which is hardest and which is softest? No. You can compare two things only when they are expressed in similar units. So, to be able to compare, like for instance, I say that a place A is say 5 kilometers from my place. Place B is say 500 meters from my place. Now, which is far and which is closer? We know that 500 meters is closer and 5 kilometers is far. So, why we are able to say that? Because we know the units, we know the interconversion of units, and we know that 5 kilometers is nothing but 5,000 meters. So, this we were able to do because we were expressing either even if we were expressing in different units, we knew what is the relationship between the units. Now here when you are expressing in these three terms, then in that case you cannot say which is the hardest and which is the softest because you do not know the relation between them. So to express hardness in one common parameter, we express it in terms of equivalents of CaCO3. So that is the basic reason why you are expressing it in terms of equivalents of CaCO3. Now in the next slides, I will tell you how it is converted into equivalents of CaCO3 and what you can do, like how you can convert and then how you can compare. So hardness, it is calculated in terms of equivalents of CaCO3 and the simple formula for that is this: mass of hardness producing substance into chemical equivalent of CaCO3 divided by the chemical equivalent of hardness producing substance. By the term chemical equivalent, we mean equivalent weight. So when you are saying calcium carbonate, so what is the equivalent weight of calcium carbonate? It is molecular weight divided by the valence factor, or the valency. So molecular weight of calcium carbonate is 100 and the valence factor is 2, so its equivalent weight becomes 50. Similarly, suppose you have calcium chloride. Now the molecular weight of calcium chloride is 100. See, chlorine is 35.5. So 35.5 into 2 will make you it 71, and you add 40 for calcium, so 111. So equivalent weight for calcium chloride will be 111 divided by 2. So suppose your water sample contains calcium chloride, then when you have to convert it into equivalents of CaCO3, what you are going to do, whatever is the weight of calcium chloride given in the question, so you put that weight over here. Then equivalent weight of calcium carbonate is 100 by 2 and the equivalent weight of calcium chloride is 111 by 2. So when you solve it, you will get hardness in terms of equivalents of CaCO3. We will do numericals and this thing will become clear to you in the next things. Now this is exactly the same thing what we have studied earlier. So now here one more thing I would like to tell you. When you are talking about a particular salt, then this term, which term? This ratio, chemical equivalent of calcium carbonate divided by chemical equivalent of hardness producing substance, this is constant for a particular compound. Like for instance, when you are talking about calcium chloride, this ratio will be 100 by 2 divided by 111 by 2. So this will always be fixed. The only variable factor will be this, that is the mass of hardness producing substance. That will be the variable factor. So this ratio, chemical equivalent of CaCO3 divided by chemical equivalent of hardness producing substance, this ratio is called the multiplication factor. So remember one thing, you need not learn multiplication factor. You know the atomic weights of different atoms. So you can calculate the molecular weight and you will be able to calculate equivalent weight also. So when we do numericals, you will be able to understand better. Anyway, just right now we are focusing on the theoretical aspect of it. So the hardness in terms of equivalents of CaCO3, it will be mass of hardness producing substance into multiplication factor. What is this multiplication factor? It is the ratio of chemical equivalent of CaCO3 divided by the chemical equivalent of hardness producing substance. Now this is the table which will tell you about, this is the table which will very clearly tell you about the multiplication factors. See, calcium bicarbonate, you can see calcium bicarbonate Calcium bicarbonate, the molar mass is 162. So the equivalent weight will be 162 by 2 and multiplication factor will be 100 by 2 divided by 162 by 2. See, you need not learn all these because when you are doing the numericals, you automatically you will be able to understand. Similarly, magnesium bicarbonate, so the multiplication factor will be 100 by 2 divided by 146 by 2. Calcium sulfate, it will be 100 by 2 divided by 136 by 2 because the molecular weight of calcium sulfate is 136. Calcium chloride, we have already discussed, it is 100 by 2 divided by 111 by 2. So like this, you can calculate the multiplication factors of different compounds and then you can convert it into equivalents of CaCO3. So now you can see this is actually, you can just see the numericals for the conversion. So here, this is the first numerical. A water sample contains 248 milligram calcium sulfate per liter. Calculate the hardness in terms of calcium carbonate equivalents. Now we just place the sum we place the values in the formula which we had studied earlier. It is mass of hardness producing substance into chemical equivalent of calcium carbonate divided by chemical equivalent of calcium carbonate divided by chemical equivalent of hardness producing substance. Now the values are given here. Mass of hardness producing substance is 248 into 100 by 2, that is the chemical equivalent of calcium carbonate, divided by chemical equivalent of hardness producing substance, which is 136 by 2. So when you solve it, you will get 182.35 ppm. Here you have to write this is hardness in terms of CaCO3 equivalents. Now this is very important, that every time we have to write in terms of CaCO3 equivalent, so that we know exactly whether it is calcium sulfate or it is calcium sulfate expressed in terms of equivalents of CaCO3. Now this is another numerical. A water sample contains 20 milligram per liter of calcium sulfate and 32 milligrams per liter of magnesium chloride. Calculate the hardness in terms of equivalents of CaCO3. So here solution once again, step 1, what you have to do is, you have to convert it into equivalents of CaCO3 and then you add to get the total hardness. So how we are going to do that? So let us see. See what we have done here. Mass of hardness, again we have taken the same formula and we have placed the value in the formula. The question says 20 milligrams per liter of calcium sulfate. So it is 20 into 100 by 2. What is 100 by 2? It is the chemical equivalent of calcium carbonate divided by 136 by 2, which is the chemical equivalent of calcium sulfate. So when you solve it, you will get 14.705 milligram per liter. In terms of equivalents of CaCO3, it is very important to write this, because the hardness which is caused by 20 milligram per liter of CaSO4, when expressed in terms of calcium carbonate, it comes to 14.705. Similarly, when you go to magnesium chloride, the question says 32 milligrams per liter of magnesium chloride. So when it is magnesium chloride, so it is 32 into 100 by 2 divided by 95 by 2. 95 by 2 is the equivalent weight of magnesium chloride, and when you solve it, you get 33.684 milligrams per liter in terms of equivalents of CaCO3. So total hardness will be, you add these two, total hardness will be 14.705 plus 33.684, that is 48.389 milligram per liter in terms of equivalents of CaCO3. So this is important, that every time you solve, you have to mention that this is in terms of equivalents of CaCO3. Now we'll do a few more numericals. Now here also, how many grams of ferrous sulfate? How many grams of ferrous sulfate here? How many grams of ferrous sulfate dissolved per liter gives 300 ppm of hardness? Now here hardness is given and you have to find out the mass of hardness producing substance. So what we do here is, we write the hardness is 300. Mass of hardness producing substance is X, because you have to find it. Equivalent weight is 100 by 2 divided by 152 by 2, because the weight of molecular weight of ferrous sulfate is 152. So when you solve it, it will be 456 milligram per liter, or it is 0.456 grams per liter. So if you dissolve 456 milligrams per liter in of ferrous sulfate, then you will get 300 ppm of hardness in terms of equivalents of CaCO3. Now let us go to the next thing, units of hardness and their relationship. Now what is hardness? Hardness is what? It is nothing but it is a solution of calcium and magnesium salts and water. So just as you express the concentration of any solution in, it is expressed in milligrams per liter, but since here the concentration is less, so these are the 4 specific units which are used to express hardness. So what are these units? One is parts per million, second is milligrams per liter. Then we have 2 units which are not used very frequently. One is degree Clark and second is degree French. So let us write down. The first one is parts per million. So it is defined as the number of parts by weight of calcium carbonate equivalent hardness. See, it is important. Whenever we are talking, we say calcium carbonate equivalent hardness. That means you have to convert hardness due to any particular compound in terms of CaCO3, and you have to always express it in terms of CaCO3. So it is defined as the number of parts by weight of CaCO3 equivalent hardness in 1 million parts of water, that is 10 raised to power 6 parts of water. Now the another unit for hardness is milligrams per liter. It is defined as the number of milligrams of CaCO3 equivalent hardness present in 1 liter of water. Similarly, the third unit is degree Clark. It is defined as the number of grains of CaCO3 equivalent hardness per gallon of water. Now, 1 grain is 1 by 7,000 pounds and 1 gallon is 10 pounds. So, the ratio of solute to solvent will be 1:70,000. So you can express it like this. You can rewrite the definition as 1 degree Clark can be defined as the number of parts of CaCO3 equivalent hardness per 70,000 parts of water. Similarly, degree French, another 4th unit is degree French. It is defined as the number of parts of CaCO3 equivalent hardness in 10 raised to power 5 parts of water. Now, these are the 4 units in which hardness is expressed, and when you derive the relation will come something like this. 1 ppm is equal to 1 milligram per liter is equal to 0.07 degree Clark is equal to 0.1 degree French. Now, how we come to this relation? See, as we defined, 1 ppm is what? It is 1 part of CaCO3 equivalent hardness, 1 part of CaCO3 equivalent hardness in 10 raised to power 6 parts of water. 1 milligram per liter is 1 part in 10 raised to power 6 parts of water. Degree Clark, 1 part of CaCO3 equivalent hardness in 70,000 parts of water. Degree French, 1 part of CaCO3 equivalent hardness in 10 raised to power 5 parts of water. That means the solute is 1 part, solvent part is varying. So we just equate it like this. 10 raised to power 6 ppm is equal to 10 raised to power 6 milligram per liter is equal to 70,000 degree Clark is equal to 10 raised to power 5 degree French. Now, if you have to find out 1 ppm is equal to how many of the other, so what we do is we just divide it by 10 raised to power 6. So when you divide it by 10 raised to power 6, you just see you will get 1 ppm. This will work out, this will cancel out and it will give you 1. This will cancel out, it will give you 1. This when you divide you will get this, and this when you divide you will get this. So 1 ppm is equal to 1 milligram per liter is equal to 0.07 degree Clark is equal to 0.1 degree French. Similarly, if you have to measure in terms of other units, say I have to measure 1 degree Clark is equal to how many of these? So in that case, what I will do is I will divide it by 70,000. So if I divide it by 70,000, all of these by 70,000, so you can see when you divide it by 70,000, you get 1 degree Clark. When you will divide it, you will get 1.433 degree French is equal to 14.3 ppm is equal to 14.3 milligrams per liter. So this is how you can express in terms of degree Clark. Similarly, now if you have to find out 1 degree French is equal to how many of the other units, then in that case what you are going to do is you will divide it by 10 raised to power 5. So you divide all by 10 raised to power 5, and when you divide it by 10 raised to power 5, you will have 1 degree French is equal to 10 ppm is equal to 10 milligram per liter is equal to 0.7 degree French. Clark, sorry. Out of all the relations that you have studied, this first relation is the most important, and you will be using this relation very frequently when you are doing the numericals. So this is undoubtedly the most important one, and you need to remember this relation by heart, because most of your numericals you will be requiring this relation. So by now I think it must be very clear to you what are the different units of hardness and how you can derive the relation between them. Now we will do a few numericals so that it becomes clear to you. So the first question is, a water sample or analysis was found to contain calcium bicarbonate 4 mg per liter, magnesium bicarbonate 6 mg per liter, calcium sulfate 8 mg per liter, magnesium sulfate 10 mg per liter. Now you have to calculate the temporary, permanent and total hardness in ppm, degree French, degree Clark. Now this question has given you the molecular weight. This question has given you the molecular weight of calcium bicarbonate, magnesium bicarbonate, calcium sulfate and magnesium sulfate. There may be questions where this molecular weight will not be given to you, so you will have to calculate on your own. See, whenever you are doing such sums, the first and the most important step is that you have to convert all these into equivalents of CaCO3. So for that we do the numerical in tabular form, and by now I'm sure all of you know how to convert it into equivalents of CaCO3. There is one simple formula and you use that formula and it will get converted into equivalents of CaCO3. So calcium we will tabulate. This is how we will draw the table as you can see on your screen. Now constituent calcium bicarbonate you have 4 mg per liter. We will write down whatever is given in the question. Magnesium bicarbonate is 6, calcium is 8 and this. Now we will convert it into equivalents of CaCO3. So when we convert this calcium bicarbonate into equivalents of CaCO3, you get the answer is 2.469 milligram per liter. Similarly, when you convert magnesium bicarbonate, so how much weight of hardness producing substance is 6. Equivalent weight of CaCO3 is 100 by 2. Equivalent weight of magnesium bicarbonate is 146 by 2. So when you solve it, you get 4.110 milligram per liter. Similarly, calcium sulfate, when we convert, it is 8 into 100 by 2 divided by 136 by 2. We get 5.882 milligram per liter. Similarly, magnesium sulfate, the question says 10 milligram per liter is there. So weight of hardness producing substance is 10. Equivalent weight of CaCO3 is 100 by 2 and equivalent weight of magnesium sulfate is 120 by 2. So it will be 8.333. Now temporary hardness is due to calcium bicarbonate and magnesium bicarbonate. So when you are calculating temporary hardness, you have to add these two which you can see in green, because temporary hardness is caused due to bicarbonates of calcium and magnesium. So you will add these two and you will get temporary hardness. Permanent hardness is caused due to other than calcium sulfate and magnesium sulfate. So you will add these two which are shown in blue. So you add these two and you will get permanent hardness. And for total hardness, what you have to do is you have to add all the four and you will get total hardness. or you can add temporary hardness and permanent hardness, and you will get total hardness. So this is how you can find out the temporary, permanent and total hardness. See here, temporary hardness, when you solve it, when you see, you can see calcium bicarbonate and magnesium bicarbonate has been added, and you get 6.579 milligram per liter, and 1 milligram per liter is equal to 1 ppm, so it will be 6.579 ppm. So what you have to do, first you have to calculate in the unit which is given in the question. Here it is milligram per liter. Now you convert it. Now 1 ppm is equal to 0.07 degree Clark, is equal to 0.1 degree French. So this milligram per liter you multiply by 0.1, you will get 0.6579 degree French. So you have the answer in degree French. So you have converted it into degree French, right? Now if you have to convert it into degree Clark, you multiply this with 0.07, you will get it into degree Clark. So this is how you can convert these into different units. Similarly, permanent hardness, as I told you, we add hardness due to calcium sulfate and magnesium sulfate. And then in that case, after that, what we are going to do is, we get it in milligram per liter or ppm, then you multiply by 0.1. So you get it in French, then you multiply by 0.07, you get it in degree Clark. So this is how you get it. And for total hardness, you add temporary hardness and permanent hardness, and I think you can do it on your own. This is, you should be able to do it on your own. So this is how we can convert it into different units of hardness. Now we come to next question. This is also a similar question. You have 3 water samples P, Q and R. They were analyzed for their salt contents. Sample P was found to contain 155 milligram of magnesium carbonate per liter. Q was found to contain 800 milligrams of calcium nitrate and 2.5 milligrams of silica and 5.1 milligram of sodium chloride per liter. Sample R was found to contain 15 grams of potassium nitrate and 3 grams of calcium carbonate. Now you have to find out the hardness in ppm and grains per gallon. Now remember, grains per gallon is nothing but degree Clark. So whether you calculate in grains per gallon or you calculate in degree Clark, it is one and the same thing. So again we follow the tabular approach. Magnesium carbonate, we convert it into equivalents of CaCO3. So when you will solve it, you will get 184.52 milligrams per liter. Similarly, in sample Q, calcium nitrate, we convert it. Now you know how to convert it. Now here remember one thing, that hardness is not caused by silica and sodium chloride. So when you are solving the numerical, this is given in the question, but you don't have to consider this. You have to just forget it. So that is why I have not included these here. Here R also the same thing is there. So when you solve it, sample P has hardness 184.52 ppm, Q has 487.80 and R has 3000 ppm. Now you can convert it. See, I told you grains per gallon and degree Clark is one and the same thing. So you multiply by 0.07, 0.07, 0.07, you will get the answer in grains per gallon. So this is how you can convert all these. You can calculate in one unit, you can convert it into another unit, and this is how you can find out the temporary, permanent and total hardness of water. I think in this lecture it must be very clear as to how you will be using all these units. Now this is the book that I have used for reference. So this is Engineering Chemistry. Book has been written with the publisher Cambridge University Press. So you can search it on internet. Now this is the back cover of the book. So this is all I have dealt with in this chapter. These are the links of this book. You can have a look at these links and you can have a look at this book. So with this we come to the end of the second lecture, in which I have explained you what is degree of hardness, how hardness can be converted into equivalents of CaCO3, why you are using CaCO3 to measure hardness, what are the different units of hardness, how you can convert hardness in one unit into hardness in another unit. So thank you all, and I think with this you will be able to solve more numericals of this type. So thank you once again. Now we will meet in third lecture where we will take up boiler problems due to hard water. Thank you.